everyone. My name is Dr. Mohammed Abdul Khaleel. I am working at LIET Institute of Engineering and Technology, Hyderabad, UGC Autonomous. I have 27 plus years experience, international experience in teaching and academics. So today I am starting a lectures. I am starting a series of lectures on applied machine learning using Python. Today's lecture will see the topic Introduction to Machine Learning. So the topics to be covered, there are 5 topics today. We'll be covering 5 topics today. The first topic is Introduction to Machine Learning, then types of machine learning, overfitting and underfitting, typical machine learning flow, implementation of machine learning in Python. We have the outcomes of this lecture, but we'll see this at the end of the lecture. So there are some prerequisites. Actually, it is not mandatory. You should know these topics. But if you know this topic, you will get the more benefit. You will get 100% benefit from this video lecture. So the knowledge of first prerequisite knowledge of Python programming language. Then you should have an simple ability to read and write the files like JSON file, CSV file, and you should have some basic knowledge of exploratory data analysis, and you should have familiarity with the Jupyter notebook. Though these are the prerequisites, but if you are not familiar with this also, you can get benefited from this lecture. So the first we will see what is machine learning. So before that, we'll see, we know that humans learn from the past experiences, and the machine follows the instructions from human. And the machine learning is it gives the capability. It's a field of computer science which gives the ability to the machine uh, to learn using the data. To learn using the data, it gives the ability, and actually, it's the subset of AI. It's a subset of AI, and it gives the ability to the machines to learn without explicitly being programmed. We know there is a traditional way of programming, so we will see what is traditional way of programming. You will open a file, you write a program, you will compile, and you will run, and you will get the output of that program. But in the machine learning, what is happening? This is all we are not doing these steps. Just we are training the machines to get the output. How we are training that will in the coming when we progress in this lecture, we'll see that. But the main thing is we'll provide the data to the machines. We'll provide some data to the machines and the desired output. So the machine will predict the results. So we'll see the one example. Actually, we have one example like you want to search a particular model of mobile. Okay, you want to search a particular model of mobile on any e-commerce website, like say Amazon. You go to Amazon and search a particular model of mobile, and you forget that. But what is happening is when you come next time when you come and open your Google website and you try to browse some data for other purpose, the Google keeps on the advertisement of that mobile which you have searched previously. It keeps on coming. So how this is being done is, this is machine learning. Actually, what you have to understand how the machine learning is working. The Google engine has learned from the machine, learned from the data you have searched previously, and it's giving you the more options about that model of mobile which you want to purchase, and it makes you to purchase that mobile. So this is how it is controlling your emotions, your priorities to purchase that mobile. So this is done using the machine learning. This is a simple example of machine learning. Then we will see one more example of machine learning, how the core idea of learning from data. Actually, we'll see the example of predicting the house prices. We are here in this example, you can see in the slide, we have four features here. We have size in square feet, the bedroom, number of bedrooms, then we have the age of the building, and the fourth column is the price. So here what we are doing, we are predicting the prices of the building or flat depending upon the other three features. So we'll see how we are doing that. So the features, we have the variables, input variables are size of the bedroom, then we have the size of the flat, number of bedrooms, age. These are the independent variables. Independent variables, we are giving the input, and the target variable is the price, where depending upon the our input variables, it is predicting the price. What we are doing is we are training the machine with some data. Actually, we are training with machines with some data. We are giving some sample data to the machine, the number of bedrooms, then the size of the building, then the age of the building. Then what machine is doing? It is predicting the price of the building. So we are giving some data to the machine. Then ultimately, what is happening? Our goal is to predict the price of the building. Okay, so in the you can see in the last line what we have done. We have given the size of the flat is 2500 SFT, and the number of bedrooms are 7, and the age of building is 7 years. So depending upon these features, the price of the building is predicted for $475,000. So this is done by the machine. Okay, but it is like just we are giving the input, we are giving some sample input, and it has predicted, depend upon our inputs, it has predicted this price of the building. So this is a simple example of the machine learning. Then we will go to the second topic. We have there are three main types of machine learning. The first one is the supervised learning. The second one is the unsupervised learning. Third one is the reinforcement learning. So totally, what you have to remember, we have three types of machine learning. One is the supervised learning. The second is the unsupervised learning. Third is reinforcement learning. So first we will see the supervised learning. What is supervised learning? The most common type of learning is supervised learning. The data set in this is labeled. Actually, the data set in this is labeled and paired with the correct answer. So in this supervised learning, everything like it is guided by a teacher. You can take an example like the predictions are guided by a teacher. So we have the input and we are pairing with the correct answer. So the thing is like we are giving in this also we are giving the data to the machine and it is predicting. So this one actually we have two types in this. Again, this supervised machine learning is divided into two categories: regression and classification. So what is regression? Predicting a continuous numerical value. So we are using the regression when we want to predict a numerical value. Like the previous example, we are predicting the price of the house, that is a numerical value, and it is continuously changing. It is not same. So today the price of the building may be some amount, and after 15 days the price of the building will be some other amount. So but this is all taken care by the supervised learning. So the other problems we can solve using the regression. Supervised regression is stock prices, temperature. Like we can predict the tomorrow's temperature. We can predict the coming 1 week temperature using this regression. Okay. So the second subcategory of supervised learning is a classification. Okay. Classification is predicting a discrete or category or class. So classification, what we are doing here, we have the two categories, two classes. Like take the example of email. We have the email. We have a data set of the email. So what we are doing, we are having the The classification, actually it is a predicting a discrete structure or a class. Okay. So next, in the subcategory of the supervised learning, next we have classification. It is predicting the discrete values. Okay, discrete values in the uh, discrete values, like if you have a data set, email data set, we can just differentiate whether it is spam or not spam, or we can recognize the image of the cat, dog, horse, or we can do the sentiment analysis. So image recognition you can do, sentiment analysis you can do using the classification. You can solve this type of problems. Then the second type of learning is machine learning is unsupervised learning. The In this, the data is unlabeled. The algorithm tries to find the hidden patterns. So it is like learning that without teacher. So the learning without teacher, the algorithm will find the hidden patterns and the hidden what are the hidden relationship between the data. So we have again two subcategories in the unsupervised learning. One is clustering, and the second is dimensional reduction. Clustering, we can solve the customer segmentation, the problem like customer segmentation, gene grouping the similar genes, then with similar expression patterns. Then we can do the dimensional reductions. But we have to remember that without data being the main data being lost, we can do the dimensional reduction. Example like reducing the 100 dimensional data set to the 2D plot. The third type of machine learning is reinforcement learning. In this type of machine learning, the algorithm learns by interacting with the environment. Okay, it gets reward for a good actions and the penalties for the bad ones. So the example of this type of learning is like AlphaGo, and we have self-driving cars and the robotics. So we will see after this, we will see some core concept of machine learning. So the core concept of machine learning is the model. Okay, the model, we'll see the model. The model is represented by a mathematical function. You can see y is equal to w1 x1 plus w2 x2 plus b. So where w1 x1, you see here, this is the equation where W1 and W2 and B are the learned parameters. And in classification, the model is decision tree and logistic regression. The second type of this core concept of machine learning is training. Training is the process of using the data to fit the model. Already we are seeing, we have discussed how we are training to get the result, to get the how we are training the machine to get the desired result. So we are giving the input and the correct output, and we want the machine to predict the values for us. Then this is the training model using the machine learning algorithm. This is the training model. What we are giving, we are giving the input plus target to the machine learning algorithm, and it is predicting the target. So in the previous example, we have seen the prediction of the house price. We have given the parameters, the like variables like the size of the house, the number of bedrooms, and age of the building, and it has predicted the price of the house. So this is how the flow is the model of machine learning is working. The algorithm is working in this manner. Then we have the prediction. As you know, prediction by the word itself, you know, we are predicting. Okay, this is also an important step of machine learning. In machine learning, then we have the generalization, is the ability to generalize the solution. Actually, we have to have a solution which is applicable to all the types of data. So it should not be specific to some data only. It should work for all the all the data sets. So this is called the generalization. Then we have overfitting. What is overfitting? Overfitting is like the model works very good on the training data. Okay, but after if you give the new data, the model will not give the correct result, because the machine is trained on the noise also. So you will not get the correct output in this case. So this is called overfitting. That it is not giving the correct result, because the machine is memorizing the data set, and it is giving the result for that data set only. And if the second disadvantage is, like, it is learning from the noise also. And if you are giving the new data set, then it will not work properly. So this if you have the overfitting problem, your machine learning algorithm will not give you the correct result. See, this figure you can see, it is in this, the two types of fitting are illustrated in this figure. The first one is appropriate fitting, the second one is overfitting. So you can see the boundary, the boundary with the red color, the curve. So it is differentiating between the two classes. It is actually, this is illustrating a classification problem. So in appropriate overfitting, what is happening? The algorithm is differentiating between the two classes, okay, and the differentiation boundary is very clear. But in the overfitting, what is happening? Our decision boundary, it is very complex, and you will not get the correct result in this case. So after that, we have one more problem is underfitting. So underfitting happens when the model is too simple. In this case, you will not get the correct result. The model is too simple. It will both training and validation errors are high and similar. So this type of machine learning, if you are having this underfitting problem also, it will be problem, will not get the correct results. So this is actually, this figure illustrates the three types of fitting. Okay, three types of fitting. The first one is with the underfitted model. So underfitted model, what it is doing, it doesn't capture any logic. The underfitting model, it doesn't capture any logic. Then we have a high loss. Then we have low latency. Then a good model, what is the characteristics of the good model? Capture the underlying logic of data set, low loss, high accuracy. And we have overfitted model. Overfitted model also will not work for us. It will capture all the noise, thus miss the point. Low loss and low accuracy. So these are the three types of fitting of the data set. So the actual, what our desired one is a good model. Okay, if you have a good model only, you will get the correct results. Then we have the typical machine learning flow. Okay, so how the machine learning, step by step, we will see how machine learning is working. So we want to build a ML model in an iterative process. Here are the key steps. We'll see there are steps in the building a machine learning model. So the first one is the data collection. So we have to, the first step in the machine learning model is data collection. So data collection, what we are doing, we are gathering the data from the various sources, and we are unifying that one. We can get the data sets from different sources. The data sets may be in pieces and parts, but we have to combine to make it one data set, to build our machine learning model. The second step is data preparation and cleaning. This is the most important actually. If you have a noise in your data, if you have the missing data, so this is it will create the problem. So we have to solve this problem, like missing data and remove the noise from the data. So all that cleaning we have to do, then only our data set will be ready for building a machine learning model. Then we will see the third one, exploratory data analysis. Use the statistics and visualization to understand the data patterns. What we are doing in this step is we are converting our data set to the visualization, okay, and checking the data patterns and relationship among the data set. So this is also very important step. So then the fourth one is feature engineering. What is we are doing? We are creating a new feature from the existing one. So that is more effective, which is more effective. Like we have a date feature, you might extract a day of the week. From the date feature, we can extract the day of the week. So this is the fourth step of machine learning. Then we have the fifth step of machine learning, model training. So in this model training, what we are doing, we are splitting the data set into two parts, training set and the testing set. Training set, it is usually we are making 70 to 80%, and the testing set 20 to 30%. Then comes the sixth step, model evaluation. So once you build the model, we have to evaluate its performance. So in this step, we are evaluating our model performance. Then for regression, if you are using the regression, then the metrics is like mean absolute error and R squared. Then for classification, the metrics like accuracy, precision, and recall. Then comes the final step in of building machine learning model, that is deployment and monitoring. So once your model, you finish with the evaluation, what you will do is you will implement that model, okay, with the real application. You will integrate with the real application, and after that also you have to keep it, its performance should be monitored on a regular basis. So then the question comes is, there are many languages. Why we are only using the Python language for machine learning? So we'll see some of the features of the Python here. Python is dominant for several key reasons. So the first reason is the rich libraries of Python. We have powerful libraries in Python, like we have NumPy, we have Pandas, we have Scikit-learn. So these are the NumPy is efficient for numerical computations. Pandas we are using for the data manipulation. For Scikit-learns we are using for the ML algorithms, for clustering, regression, classification. For this all we are using the Scikit library. Then more libraries we have Matplotlib, Seaborn for the data visualization, TensorFlow and PyTorch, powerful libraries for building training complex deep learning models. For TensorFlow, we are using for the deep learning models. Then we have it is simple and readable. The second advantage, apart from the rich libraries of the Python, it is simple and readable. It is like more or less like an English language. The syntax is very simple in the Python. The syntax is very simple compared to the other languages like C or C++ or Java. The syntax of the Python is very simple. So and the length of the code also, it is very less compared to the other languages. Length of code is very less. So we will see one example. Actually, we will build a machine learning algorithm using the machine learning algorithm supervised learning classification. Will implement this using the iris dataset, flower dataset. Okay, the goal of this is to predict the species of an iris flower based on the measurements of its petal and sepal length. So this is the implementation, actually how we are implementing the machine learning model. So first what we are doing in the first step, we are importing the libraries. These are the required libraries we are importing, Python libraries we are importing. Okay, this is the first step in the implementation. Then we have the second step, we are loading the data set. Okay, the data set name is iris. Okay, then what are the features of the data set? We have sepal length, sepal width, petal width. Okay, and we have to find the target. Why the variable y? We are finding the target, the species of the flower 0, 1, and 2. Then we are splitting the data into training and testing set. as we have discussed, these are the steps of building machine learning. So we are actually implementing using the Python. So in this, we are splitting the data set into training set 80% and testing set 20%, and we are randomizing this by using the random underscore state is equal to 42. After that, we choose and create a model. So here we are using the decision tree classifier. Okay. Then we are training the model using the training data. Then we are making the predictions on the test data. Then the seventh step, evaluate the model performance. After that, we are evaluating the model performance, like model accuracy. What is the model accuracy? And final, we are predicting the species of the flower, depending upon the sepal length and sepal width, petal length and petal width. We are predicting the species of the flower. So we'll see the output is species of the flower, Sitosa. So we'll just see, actually I want to just show you the flower of the iris. Iris flower is like this, okay? So you are seeing the big leaves, that is the sepal, it is called sepal, and the small leaf, it is called petal. So these are the iris flower. So if you have the knowledge, it is also a type of exploratory data analysis. So we are just seeing the picture of the flower so that we will have a better idea how to solve the problem. So now we have the three types of flowers here. As we have discussed, we have given this the numerical 0, 1 and 2. We have the first species is Sitosa, the second species is versicolor, the third species is virginica. So we have the three types of species of the flower here. Then we will just see the practical implementation of this. So this is the actually online compiler, one compiler. We'll see how to just use this one. Okay. So the first here you can see the first step. We are importing the libraries, required libraries. Scikit-learn is the Scikit library. Okay. We have just we have this one we have imported these libraries. Okay. Scikit-learn, from this we have imported these functions, and we have load iris. Okay, this is the inbuilt function of the Python. So and we have imported all this for train test split function, decision tree classifier, and accuracy. Okay, from using the Scikit-learn library. Then the second step, what we are loading the data set. Load iris. This is the data set name. So we have the features here. We have the x variable. In this, we are storing the features. What are the features? Features are the sepal length, sepal width, petal length, and the petal width. And y is our target variable. In this, we have to predict the species of the flower. Okay. So we have in X we have the features which we are giving the input, and Y we have the features which we are getting the output, species of the flower. Then we are splitting the data. Then we are splitting the data set into two parts. Okay, that is 80% we are for the training, and 20% for the testing. After that, we are after that after splitting the data, we choose and create the model. Okay, we are choosing the model decision tree classifier. Okay, here we are choosing the to solve this problem, we are choosing the decision tree classifier. After that, we are training the data set. What is training data set? We are training this data set model with the data to fit the model. Okay, to fit the model. After that, what we are doing in the second step, we are evaluating the model. Okay, this is a very important step. Once you predict, then you have to evaluate. Without evaluate, you will know you don't know whether your prediction is correct or not. So here, what we are finding, we are finding the accuracy. Here you can see you are finding the accuracy of the model. Okay, we are calculating the accuracy of the model. and in the final step we are predicting the species of the flower. Okay, so the here we have this output. You see the model accuracy, it is 1. So that means our model is 100% giving the correct result, 100% result, and it has given the species. Okay, species of the flower is setosa. So just now we have seen the compilation, how we are solving the machine learning problem. Step by step we have seen that. Now we will see the summary of this topic, this lecture. Actually summary of this topic is introduction to machine learning. So machine learning is about teaching computers to learn the patterns from data uh, to make a predictions or decisions. Okay, so we have covered this one. Then we have the three main types of learning. We have supervised, unsupervised, and reinforcement learning. We have covered this topic. Then we have seen the workflow involves the data preparation, model training, and evaluation. We have finished this one. Then we have discussed the Python libraries. Okay, we have used the Python libraries for solving the machine learning problem. Okay, so the final takeaway is this field is powerful and is behind many modern technologies, from recommendation systems, Netflix, Amazon, or to voice assistant. So all the big giants are using this machine learning to solve their problems. So you can also get benefited from that by learning the machine learning. So now we already covered these 5 topics. Then the final outcome of this course, the define what machine learning is and how it works from the traditional programming. This we have covered. Then translate a real world problem into the input features and target variables. We have seen the enough examples. Okay. Then describe the types of machine learning: supervised, unsupervised, and reinforcement. This also we finished. Explain the fundamental notions such as model training, prediction, generalization, overfitting, and underfitting. We have done this one. Okay. Then understanding the typical machine learning workflow. We have done this. Okay. Using the example also. Train and evaluate the models. Okay. Yes, we have done this using the online execution. Okay. Then why is Python language for machine learning? We have seen the advantages. We will be continuing this topic, actually applied machine learning using Python. So next our video will be on introduction to Python. Thank you for watching. Subscribe for more videos. Thank you.